in a protected mine, in a protected shaft, and Gazabay is located near the launch pad. So when taking a rocket off the Gazabay, the shaft and the elevator, we will experience tremors, loss, and vibration. Usually, elevators with cannot work in such conditions. So this is a very hard condition to, this is a station. This is located just near the rocket during the launch. So this is a really hard condition. And we have developed a unique protective shaft, which helps to protect the elevators from vibrational impact, from a gas dynamic streams of rocket, from environmental exposure inside. The stable temperature and humidity are maintained because, in the Kazakhstan, this is a very hard condition because at the summer it's something about +15, +50, +40, and at the winter is -40. So it's really hard to work in this condition. Right now I'm going to speak a little about my artistic project, because when I was an engineer, I started to continue my education in ITMO University. Maybe you know the ITMO University, maybe you know. This is a big university who specializes on the different informal IT sphere. They produce some people who works in AI and something like this. Yeah, and in fact, this is it was really easy because we started to develop in different things, because I get the degree in Master of Science in Innovation in this university, but in fact we do a lot of beautiful things. We started to know how to make a business in innovation, and we continue to create different beautiful things in the art sphere, for example, in sound art and AI art and so on, and DCI, and we started to connect it with different research institutes inside the university and outside university. So really wonderful way. Okay, the last, I think, but not least, project. This is my artistic nickname, Roman Clouder. I have a website right now, but this is under reconstruction, so you check it later, maybe the next week. The first project is Coven. This is the audiovisual special performance. This is a video art, and the project inspired by the mystical works of Nigerian writer M.S. Tutuola. The artist Merimaka created she and the beautiful illustrator and director of animation movies. She created the graphic project in this forest and animated script, which became a basis for script for the visual performance. And I brought music using my own vision and African field recordings, synchronized sound and musical instrument to create atmosphere and magical and slightly frightening world. And Mary Mack created the animation video. And this composition is dedicated to the coven of the forest spirits. This is a personified human fears. In the African tradition, if you have any type of fear, for example, in the night, in the middle of the night of the forest, you hear something, and maybe it will scare you. But if you give it the name for this, you can control it. You don't afraid these things anymore, because it thinks has his own name. And this project based on this idea. I also make a few performances in different countries, because this is a live composition. This is a live composition with this is a special spatial performance. It means you have a lot of loudspeaker around you, and you can control the level of the sound from each loudspeaker. And you can create a beautiful sounds around you, and the listeners also sit inside this sphere of the sound. So this is a special composition because in different location you can hear the different combination of different sounds. So this is a unique situation because you also can move this sound around you to make us so beautiful. This is a photo for the performance from the gallery and different country. Also, I have. Let's try to listen a few things. Maybe we can. Maybe no. I'm not sure. Did you hear anything? No, right now. Okay. Okay. Unfortunately, no. Maybe. And now? Mm-hmm. Maybe. Okay. Okay. Next time, it's not a problem. The second project I'm going to talking about today. This is the imaginary music. I remember this. Just to talk a little about the BCI art and something like this. But in fact, this is a in the field of art and science. This is a combination of art and science. The project this is the creation of the idea, the main idea. It's creation of a neurointerface that converts the brain signals into imaginary music in real time. I made this project with cooperation scientists of the Research Institute of Pablo. They have a lot of beautiful things, and they have a big experience how to do this. And they conduct this experiment with audio stimulus and recorded brain activity. I came to this university with my idea, and we found the researcher and scientist, and they helped me to create a few experiments and record my brain waves during the when I listen to the music. We made a few special stimulus for this because in music it's a very complicated things. It's very complicated things because there's your brain in EEG or maybe in EMG it looks like a candle or New Year's tree, because every part of your brain in working during when you create the music or listen to the music and so on. So we decided to start from the little simple things. We create a very simple stimulus. This is it sounds like a snap. Something like this. We create this in a very special way because this is milliseconds. We created especially for these experiments because the brain has their own time to react, and we need to let our brain to react for each stimulus in this experiment. So we create two different types of sounds and record this. And we need to check. In fact, this is a very complicated project, so I get video documentation. How we do this with my commentary. We prepare for the experiment. I listen. I concentrate the red spot because after that we're trying to to process the data with a special software and to work with the neural to clean the data and to train the neural network, because we need to reconstruct this music from the brainwaves, not in just simple way, but it's a little complicated. In fact, this is something like a holy grail this time. Okay, the next one is Land of Relief. This is a sound art, special sound installation. I made with artist Ksenia Baksina for the Grounding Festival in the Ars Electronica Festival in Linz. This is a very famous and old art and science festival with different things, something like this. The main idea was when you record the brainwaves, it looks like landscapes. You can see on the photo how it looks like, and when you work with music waves in different types of software, you can also see the music, like it also looks like sound waves. So we trying to combine this idea, and we made also sound art project. Yes. Okay, let's try. Okay, nice. Let's try one more time. Okay, nice. Nice. Now you hear? Nice. This is a little nasty sound, but you know, this is the experimental art and experimental sound. This is a direct sonification. So sometimes it's sound not so good. No, but maybe unusual. Okay, I'm going to show the Coven project because it's much more easy to listen. Yo, 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 yeah, yeah, yo. Yeah, yeah, need to go no more, yo, yo, yeah, yo. Get me, need to go no more, yo, yeah, yo. Get me, need to go no more, yo, yeah, yo. It's a long composition for 12 minutes with their story, its script, and the different parts. I really love this work. Okay, are you see my screen, this presentation right now? Okay, nice.
Yep.
I'm also teach for the different types of sound art in Armenia. This is a place for young and talented people, boys and girls. I teach the sound design and animation. I was in this summer. It's a beautiful experience. The next project is Technoether. It's also like a source for the signals for communication devices, a computer, a router, a smartphone, and radio station. So this is a big cosmonium project. You know, this is a lot of. This is a big hall with a lot of loudspeaker, something about 50 or 70, and you can create your own composition and control every loudspeaker with special devices. It's also a beautiful experience. I really love it. Artistic purpose. Okay, I think we need to deep dive in the main topic of our talk. This is the Getaways to Dreams Spaceport. Do you know who is this Konstantin Tsiolkovsky? Okay, I think I need to talk about just a little. If you have any question, you can ask me wherever you want. You can stop me and ask me, because right now it's new software. I mean Microsoft Teams, so I have no possibilities to check the screen of Microsoft Teams because I'm concentrate on the presentation. So you can ask me with the voice. I didn't right now I didn't reach chat. So sorry. Nice. Thank you. Okay, Konstantin Tsiolkovsky. This is a Russian scientist and inventor. He is founder of the theory of missile technology. He develops the concept of space flights and a formula for calculating the speed of the rockets. He predicted the possibilities of interplanetary flights and the use of missile for space research. And he published works on space station, life on space, liquid fuel engines. He lived in the middle. He was born in 1857 and he died in 1935. This is a Russian scientist. This is one of the founder of theoretical cosmonautics. There are also a few famous scientists, like a French scientist, Robert Peltier. In Germany, this was Hermann Oberth, and in America, it was Robert Goddard. And Tsiolkovsky not only dreamed on spaceflight, but also developed the fundamental principles of rocket technology, many of which remain relevant today. In 1903, Tsiolkovsky published a paper titled Exploration of World Space by Jet Instruments, in which he formulated the famous equation linking the speed of rocket to its mass and the velocity of the gases. He proposed the use of multi-stage rocket. This is like a rocket train. He called it rocket train, and talked about the possibility of using liquid fuel, all of which would later become a reality. He also was a philosopher and also thought about possibilities of living in space, proposing ideas for orbital stations, space elevators, and even interstellar travel. Also, he did not have the technical capabilities to realize his ideas during his lifetime. His work inspired a whole generation of engineers and scientists. I prepared this presentation like with a few bullet point main epoch in the cosmonautic, because we don't have, and I don't have any possibilities to make a course on the history in the cosmonautic, because there's a lot of names inside. So the main names, only main names. The second one, this is the Wernher von Braun. This is a German rocket engineer during the World War II in Germany. In parallel with development of theoretical foundation in Russia, engineer Wernher von Braun was engaged in the practical realization of rocket technology. In 1930s and 1940s, he led the development of the V2 ballistic missiles, the first rocket to reach the frontier of space. In fact, the Nazi Germany used this rocket to bomb the England. And V2 used liquid propellant and could reach altitudes of more than 80 kilometers. It was the first object to make a guided flight on a ballistic trajectory into near outer space. And interesting things, I think we can discuss about it, like this is the first spaceports, because the Germany started to build spaceports for the V2 for this rocket, but every of this place was destroyed by the Allies. So they made a few, what's the name? This is they made a special mobile complexes. Only the need for the complex is just a flight ground, and that's all. It's very you need only about maybe a few hours or maybe less than day to prepare rocket to start. So this is very, very fast. Also, Wernher von Braun, he, after the war, along with a group of German engineers, he was taken to the United States under the Operation Paperclip program, where he continued to develop rocket technology and later becoming a key figure in the American space program, Saturn V, Apollo 11, and so on. I think you know these names, you know a lot of about this. Sergei Korolev. This is also key name for, if we're talking about the Wernher von Braun, this is the key name for the USA, but in Soviet Union, right now in the Russia, this is the key name for the Russian cosmonautics. He was a Soviet designer of missiles and spacecraft, and he directed the launch of the first artificial Earth satellite and the first flight of a person into space, Yuri Gagarin. And Korolev, trained as an aerodynamic engineer, became the chief designer of the Soviet space program. Under his leadership, the world's first intercontinental ballistic missile, the R-7 in Soviet Union, of course, was created, which later became the basis for space launches. Both countries, Soviet Union and USA, conducted intensive scientific and engineering development, investing huge resources in space exploration. Space became an area of competition between the two superpowers, a symbol of progress and technological superiority. And Korolev is also known as the program manager and general designer of almost all space launch and system in USSR. The first artificial air satellites, first man in space Yuri Gagarin, the first spacewalk Leonov in 18 March 1975. The first project of the orbital space station and long-distance manned flight to Mars. So it started in the middle of the 20th century. Not right now, but in the middle of the 20th century. Okay, this is the Yuri Gagarin. This is a Soviet astronaut, the first person in the space, first man in the space, and he made an orbital flight on the Vostok 1 spacecraft on April 12 in 1961. And the Soviet Union made a historic breakthrough. Yuri Alexandrovich Gagarin became the first man in space. His flight on the Vostok 1 spacecraft lasted 108 minutes, during which he made one revolution around the Earth. And the launch was accomplished using a modified R7 rocket. This rocket was built by Korolev, and it's a missile for the military, but they make a few modification, and after that, this rocket was ready to do the space flight. Okay, I made this photo. This is the R7 rocket. Right now, they continue to make space flights to the ISS space station. It's a very good constructed spacecraft. I mean, Soyuz, only with the three places inside the spaceships. In fact, this is like aircraft or like a car. They very good engineering things. Okay, space shuttle. In America is a reusable spaceship. It was used to launch satellites, the construction of the ISS, and scientific mission. USA started this project in 1981, and they closed this project in 2011. And the system included an orbiter with wings, two solid fuel boosters, and the external fuel tank. So the space shuttle was the first and so far the only system capable of regularly delivering cargo and people into orbit and returning to Earth with a horizontal landing. It played an important role to construct the ISS and the launch or servicing and the Hubble telescope. In the USSR, the answer to the shuttle was a Buran project. It looks like this. This is a complex Energy-Buran. The energy, this is a rocket, and the Buran, this is a spacecraft. It was developed in the 1980s and made its only one fully automated flight in 1988. And he made a beautiful and fully unmanned landing. However, due to the collapse of the USSR, the program was closed because it's very, very expensive things, and I think it's only the big country like a USSR or maybe USA can create this big project because it's really a lot of money. I think I cannot understand how much. Okay, let's jump for our time. In Russia, right now, we have a Angara A5 on the Cosmodrome Vostochny. This is a Russian heavy launch vehicles and designed for the withdrawal of large cargoes and orbit and interplanetary mission. The Angara A5 heavy lift launch vehicles was successfully launched from the Vostochny Cosmodrome on April 11 in 2024. This launch was the first Angara A5 launch from the Vostochny Cosmodrome and marked the beginning of the flight development test of the Amur space rocket complex. This is on the Amur, Cosmodrome Vostochny, and so on, including both the launch vehicles itself and the Cosmodrome infrastructure. Okay, this is the Elon Musk. I think everyone know who is this American entrepreneur and engineer, this founder of SpaceX, Tesla, and Neuralink, enthusiast of mass flight. This is a big new SpaceX Starship with a beautiful technology of reusable heavy launch vehicles. In fact, this technology was created in USA and in Soviet Union in the middle of the 20th centuries, but it was the technology doesn't develop enough. So right now, it's really it can be created in lasting life. So it's good idea in this time to make a reusable unit for the space flight. And SpaceX was the first in history to successfully land the first stage of Falcon 9 orbital rocket, making it reusable. This significantly reduced the cost of launches and revolutionized the space service market. And right now, the SpaceX Starship is the most powerful rocket in history. They also use the very interesting system. They call it Mechazilla. This system is located only at the Starbase launch in Boca Chica, Texas. And Mechazilla is a series tower equipped with movable manipulators designed to capture and stabilize the super heavy first stage as it returns to Earth. During landing, the stage slows in descent by engaging its engines, and the Mechazilla manipulators capture it like this to ensure a precise to safe landing. On October 13, 2024, SpaceX successfully performed the first landing on the super heavy first stage using the Mechazilla system at launch pad in Texas. Yeah, I think it's time to talk a little about what's the difference between right now I'm going to talk about the spaceports. What's the main differences in East and West tradition to make spaceports? I mean, in Soviet Union and Russia right now, or maybe some countries like China, and West countries like USA or maybe Europe. I think we have a different I think this is a tradition how to create spaceports and how to assemble the spacecraft and rocket on the spaceports. Because a different climate, in Russia and USSR, the climate is continental climate, so they have really bad condition from -40 at the winter until the +50 at the summer, and deserts and sand and big wind and rain, but the climate on the Cape Canaveral in Kennedy Space Center in USA is a sea climate and wet and good temperature from +5 until the +25, something like this. So they are different things, and I think the main difference between the USA and Russia right now in the spaceports, the main difference is that the Soviet school of cosmodromes construction grew on the military missiles logics, emphasizing security and reliability under conditions of strict secrecy. The American school focused on flexibility, vertical integration, and access to the sea. Today, both schools are borrowing solutions from each other. Russia is introducing elements of vertical assembly in Cosmodrome Vostochny, while the USA SpaceX is building more secure towers like a Starbase and Megazilma. I also have a few ideas about the future of the cosmodromes, because also very interesting things. Tsiolkovsky created this idea in the beginning of 20th century. This is a space elevator. This is a theoretical concept of lifting objects into orbit using a cable, and uses materials with extreme strength, such as carbon nanotubes. Okay, I think this is one of the most impressive and at the same time little studied project in the history of engineering, and this is the idea of space elevator or space hook. This is not a metaphor, but a literal mechanical system capable of lifting cargo and people from the Earth's surface into orbit without the use of rocket. And this idea was first proposed in 1985 by Konstantin Tsiolkovsky in his essay Dreams of Earth and Sky. He was inspired by the design of the Eiffel Tower, Eiffel Tower in Paris, France, and suggested the possibility of building a giant tower going up for the geostationary orbit. And Tsiolkovsky described an imaginary plant over which the tower bends without touching the surface. Its equilibrium is ensured by the balance of centrifugal force and the top of gravitational attraction at the bottom. So it looks like this. This is a picture from the concept of Japan company. Name of this company is, let me check. Obayashi Corporation. This is Obayashi Corporation. Yeah. You can put this station on the center of the mass for the elevator, and you need to get a counterweight to balance all this system. And they have a good idea because in 1960, Leningrad engineer in Soviet Union, his name is Yuri Artsutanov, described the skyhook concept in Komsomolskaya Pravda. This is a Sunday supplement of July 31 in 1960, with name Into Space by Electric Locomotive, and proposed a practical scheme for a space elevator. Cable fixed on the equator goes into the sky and reach geostationary orbit, and then continues counterweight. This counterweight creates the necessary tension to keep the entire structure very stable. The cars or lift or elevator then deliver the cargo where they move along the cable, not on the rocket, but with electric motors, like a cable car. And in fact, the potential such a system is very good, because It's very environmental friendly, no rocket fuel and no atmospheric emissions. This is the safety, less risk of accident and explosion during startup, and savings. The cost of lifting cargo into space can drop by a factor of 10. In fact, 10 times. This is good. And the only things holding back realization was the lack of suitable material. And cable, this is a very long cable, over 36,000 kilometers long, would have to be incredibly strong and light at the same time. This was impossible in the middle of 20th centuries. And also like idea in 1971, writer, inventor, and futurologist Arthur Clarke, who lived in Sri Lanka most of his life, wrote the Fountains of Paradise, where he described that idea that humanity can build it in 22nd century. And he believed that if he is to be built, it would be possible in 15 years. I think the progress on this situation started in 1991 when carbon nanotubes, CNT, were discovered. This structure have a fantastic strength-to-weight ratio, hundreds of times higher than steel, and they thinner than a hair, but can withstand the loss requires a space elevator. If you will try to make a space elevator, the cable for the space elevator, they made from steel. You need to make a few thousand meters, diameter near the surface of the Earth. It's too much. But if you go into create with nanotubes, it's something about a few centimeters. So it's really good. This can be realized. And current research show that scientists are theoretically strong enough to be used on the space, especially in shape and thickness, are properly matched to in height. At this moment, Japanese company Obayashi Corporation has been developing a space elevator project since 2012, which is plans to build by 2015. According to their concept, a 36,000 kilometers long cable will be made of carbon nanotubes and will connect the Earth with the geostationary orbit with a total cable length of 96,000 kilometers. And the ground station will be placed on a floating platform in the ocean with a massive counterweight in orbit. And the elevator will be able to deliver cargo weight up to 100 tons, making space flights cheaper and more environmentally friendly. Obayashi is actively investing in research and collaboration with universities and international organizations, but right now it's a concept stage. But the project is ambitious, but they want to be first when carbon nanotubes are available for mass production. So thank you so much. Thank you so much for listening. And I think right now I'm ready to listen to your question. If you have, I can try to discuss and answer.
Hi, my name is Ignacio, and it's a pleasure. And I truly love to work with music. It was amazing. And I have two questions for you. One question is a little technical question, but the first is, what kind of hardware or software do you use to capture and translate brain activity into sound? And the second question is, what advice would you give to students on engineering interest in exploring nanotechnology in music?
Okay, excuse me. I think I need to use my headphones because this sound is not a clear. Let me set up my devices. Yes, and after that, I'm ready to ask you me one more time. Second, please. Okay.
Okay.
Right now,
The first question is, okay. Do you listen me?
yes.
Okay. Okay. Cool. My first question is, what kind of hardware and software do you use to capture and translate brain activity into sound?
We use a few devices. If we're talking about the project Land of Reliefs, we use the Muse EEG device. I think this is not for the real research because, you know, the main problem with the neural interfaces like Muse and so on, because it's it's a big problem to get a very clear record of your brain waves because a lot of factors, electricity activity in the room, if you move your eyes or maybe something with your hands, affect on the records of brain activities. It's a really big problem. So you need to be in a small room without no light and concentrate on the sound of and so on on the task. So when we use the devices for the we use the Muse. It's not real scientific devices, but it's basis for meditation. But they we have a few programs to get a clear EEG from these devices and process it in max MSP because we realize that it's really hard to get to realize our concept in a proper way because a lot of things to do. But when we work on my generic music project, we use real equipment in Pablo Institute. They have their own station to record the brain activity. Unfortunately, I don't remember the name of this. This is not a mobile hardware, but they buy it in Switzerland. There's special equipment in Switzerland, and also we use the Mitzar. Mitzar, this is a special equipment for their record EEG, and it produced in St. Petersburg, in Russia, and we in clinical and scientific research all around Russia and sell it to different countries. Not so expensive, so I think many countries buy these type of devices. But we process the data in MATLAB. Use MATLAB to process the data, but you know, because this is scientific research, and when you do it in the Korolev Institute, they made their own script and they made software to process the data. So we use this. Unfortunately, I cannot say how name of this, but this is a few scripts with the also custom configuration to process everything.
Okay, that's cool. Thank you.
Yeah, and second question, no?
Second question. My second question is, what advice would you give to students or engineer student in engineering for exploring neurotechnology and music?
If I understand correctly, your question is what I am interested, why I am interested in it.
What advice would you give to students or engineers interested in exploring neurotechnology and music?
Okay, it's a really good question. Right now, I feel myself like a guru, they're from India and so on. I think I'm not a guru and I'm not ready to give a big advice because I'm people with I'm normal man with a lot of interest in my life, but I think I think you need to just do what you want to do. Um, uh, I think we have a lot of people in Instagram who talks the same things, but I think you need to find firstly what I'm trying to do. This project, I'm trying to find the people who also interested in this in the same field and trying to collaborate with as much people as possible. If you can create a big community around you, this is also very good. Also, I think you need to find, for my idea, you need to find um, a few labs or university on trying to communicate with scientists or maybe students from different universities from different countries and trying to find each possibilities what you have. If you have enough time for this, I mean, if you really want to concentrate to the BCI research, it's whatever. Maybe it's not a BCI research. Maybe you want to try to concentrate to the sound on maybe the music on the making ukulele. It's whatever, but you need to find each conference and trying to collaborate with everyone. I think it can. If you want to be a solo artist or solo engineer, it's really hard because you can develop yourself in the good environment much faster than you trying to do it alone in your room. If you have possibilities to communicate with people directly, I mean, to come to university and to talk, to drink tea or coffee and discuss about it, it's very nice. So I think this is my advice: to communicate with people.
Okay,
But thank you
thank
the
you so
question.
much.
Yeah, this is my pleasure.
No, thank you. And you have a new follower in your music account, of course.
Thank you so much.
Yes, hello, can you hear me? Perfect. Well, thank you for your presentation. It was very interesting to see the whole process.
Thank you.
And I was just wondering, where do you get your inspiration from for making these kinds of sounds, this kind of music that's very unconventional?
Okay, I think the question is the answer for this question is my environment because I developed myself in the ITMO University and a lot of very talented people around me, and yeah, I communicate with these people, and they give me inspiration, because um, I developed myself in jazz music during my study in university in Voenmech University when I started to be dreaming about to be a spacecraft engineer. I'm also started to develop myself in the jazz music. I started to play on the guitar, on the drums, on the bass guitar. But after that, I realized that I need a little more, and I started to create a musical instrument. I started dreaming about create my own bass guitar and started to create this instrument. And after that, I started to develop myself in different direction because I realized it's not enough for me. I think I think I'm artist inside my soul. Something like this. Yeah, but I'm started to my master's education in ITMO University and found a whole new world. And this is the biggest inspiration for me because different people with interesting in sound and music and art and video art and in research, and they also have a very good technical skills. And I started to collaborate with them and started to create a new idea. So it's really inspirational. But I think you can show a few of my projects. I think the three of them, they are little, four of them, and they are different because I'm trying to create experimental sound and more traditional sound. So I think my inspiration is also travel. Travel with bigger things to understand yourself. And the second one is I think I cannot live without music. I don't know how it's happened, but it's something about deep inside my nature. I can't live without music. I want to create music. I want to play on the instrument. You know, it's like an addiction. I hope I answered to your question.
Yes, thank you.
Yeah, sure, okay. Okay, space. Space elevator or rocket? I think at this moment, rocket is not a conception because space elevator is conception and we can understand it only in our future. But I think the spacecraft and rocket is more safe than their air travel right now. You know, the aviation, this brother, right? They started to create their own, you know, this second. They started to make an airplane, and the whole history of airplane is the history of crashes and a lot of catastrophe and so on. But for the space, we create the theory, and after we started to create the rocket, and so the rocket is more safe than airplane. But I'm not sure about the space elevator because at this moment this is a conception. But some people made a calculation. You can find some scientific articles on this field on the web, and they calculate this. It's this whole project will be very expensive, very expensive. But in fact, this is cheaper than space rockets. So I think this is the answer. It's cheaper and possibly it's much more safety, but this is the conception at this moment. Wow. You know, right now I'm not in Russia. I'm right now in Sri Lanka. The Arthur Clarke also live many years. This is futurologist and um, talking about it, the inventor and so on. I think the main problem with the space program and space industry, because this is connected very with the military. And if you want to work in some space programs in different countries, you need to get the citizenship in these countries firstly. Sometimes it's hard, but I think you know, all our world right now works like in way like this. You started to trying to do a small prototype and a cheap and very simple project, and you get a reaction from people around you. Maybe you going to show your idea to the internet, because right now this is a lot of possibilities in the world. I think sometimes it's not true, because there's a lot of possibilities and a lot of borders. But right now it's possibilities with the internet much more than 20 or 30 years ago. So I think you can try to make a few simple project, but with a good idea, and trying to collaborate with people who have any possibilities, maybe have money to realize your idea. Or maybe trying to collaborate inside your country and outside your country. I think this is the best idea. In fact, I think it's not so easy. It sounds easy, but I think it's not so easy. It takes time. Unfortunately, it takes time. I also want to create. I have a lot of projects, and I think about it, and I want to do it in the next months to realize everything in next months. But sometimes you need to spend a few years to create not so a big project. It just takes time. But I will remember this. I mentioned, keep in mind this question. Maybe I have a better answer for this, and I send it in your chat later. Yeah, sure. Get the brain signals. Mhm. Okay, let's discuss about it, because it's not. I think it's great question, and great question for the scientists who deep in theme, because it's different types, a lot of types of research, and a lot of types of scientific research. For example, I works with the music, with the sound. In this field, if you want to get the EEG records of the sounds of music, you need to start with very simple, very simple signals, like a snap and something like this, or maybe like a beep 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 beep, something like this. Very simple signals, because you need to process the data from the brain, and if you're trying to process the signals from the music, and a lot of things happen in music. This is a structure of the music, your imagination, your memory, rhythm, the notes, the melody, the arrangement, a lot of things happen. So I think you need to start from the simple things. But if you want to make, if you want to make records, and if you want to work with the, for example, video or maybe with the eyes, you need to read the scientific papers and read the scientific research on, for example, on Sky-Hub to find something like this. I think you know Sky-Hub, right? Yeah. I think everyone who trying to find free articles in scientific field, they know what is the Sky-Hub, because it makes thank God to girls who create this, because this makes our life much more easy. We don't have enough money to buy every articles. I think we also don't need this, in fact. So I'm not sure. I think you need to get this symbols. I think you can try to find scientists who works with the EEG and ask a few questions directly to him. I think this is a better decision.